There we go. Okay. All right. Okay, so our next section is on page 10. It's solving simultaneous equations and solving for expressions. All right, so I'm going to save you guys a ton of time and effort on these problems. So in school, this is not in your packet, by the way. I'm just going to give you a different example than what's in your packet. In school, you guys learned how to solve equations that look like 2x plus 3y equals 7, and then like 4x minus 6y equals 12 or something like that. And you had to solve for x and y, either using substitution or elimination. Okay. At some point during your math education, you ran into that. And it's kind of a long, tedious process. The good news is, on these tests, 9 times out of 10, you don't actually have to do that. Every once in a while, you will hit the rare problem, especially in your ACT, where you do actually have to solve for x and y. The majority of the time, you don't. So, let's look at the shortcuts. All right. So you have an example in the middle of your page. If 4m plus 2n is 3, and m plus n is negative 5, then what's 5m plus 3n over 2? So the long way is to find m and n and then actually figure out what 5m plus 3n over 2 is actually is. Not doing that. This method does not require much thinking. All you're going to do is take the 2 equations that they gave you, line them up, and you're either going to add them or subtract them, and your answer should pop out at you. It's that simple. Okay? So I'm going to try adding first because it's easier. If adding doesn't work, I'll go back and subtract. I'm just going to add down. 4m plus m is 5m. 2n plus n is 3n. This is the example problem. 3 minus 5 is negative 2. So I have 5m plus 3n is negative 2. Where else do I see 5m plus 3n in this problem?
Oh, the fraction?
Yeah, that's what they're looking for. They asked me what 5m plus 3n over 2 is. Aha! 5m plus 3n is negative 2. Cool. That means that 5m plus 3n, the top of this fraction is just negative 2. So negative 2 over 2 is negative 1. That's my answer, and I'm done. Okay? There is no reason to find these bloody letters. Right. Let's do another one. Any questions before I do another one? Okay? Fast. Should be very fast for you. Right. So SAT number 18, middle of your page, it's gridded. If 4y, can't even read the problem. If 4x plus y equals 14 and 3x plus 2y is 13, then what's x minus y? All right, cool. Again, I'm not going to think about this. 3x, 2y equals 13. My goal is to get x minus y. Should I add or subtract? Subtract. Okay, if I'm going to subtract, I'm going to change all the signs. And then I'm just going to combine down. 4x minus 3x is not 2. 4x minus 3x is x. Y minus 2y is negative y. 14 minus 13 is 1. Did I get what I wanted? Yeah, I got x minus y. X minus y is 1. I graded 1. I'm done. Okay. These problems should be that quick. Okay. Every once in a while, you won't get exactly what you wanted. You might get 4x minus 4y. Okay, great. If I get 4x minus 4y equals 4, no big deal. I'm just going to divide everything by 4 to get my x minus y. Okay, so every once in a while, you might get a multiple of what you want. Just divide so you can get what you want. Okay. All right, the one at the bottom of the page there, number 19, is yours to do for homework. If you are taking any more than about 30 seconds to a minute on these problems, you're working too hard. Top of the next page, SAT 14 at the top is also yours for homework. SAT number 7. The solution to the system of equations below is xy. What's the value of x? All right, so we have x plus 2y is equal to 16. And then they gave me a decimal. It's like, really? Are you serious? I don't do these problems with decimals. How can I get rid of that 0.5? Multiply by 2. Let's just multiply this by 2. I don't want that there. So I'm just going to recopy the top one. wanna multiply the whole bottom equation by 2, so, oh, I forgot to put the 2 out front. So 2 times 0.5 is x, 2 times negative y is negative 2y, 2 times 10 is 20. Okay. And then I'm gonna do what I've been doing, I'm just gonna add the equations. Add down. X and x is 2x, my y's are gonna drop out, that's handy. 16 and 20 is 36, I'm this close, I might as well solve for x, divide both sides by 2. X is 18, go back to your problem, make sure they wanted x and not y. Always double check. What is the value of x? Cool, x is 18, I got my answer, C. Ma'am?
I'm so confused, like, how did you decide to, like, multiply by 2 in the very beginning?
I want to get rid of this 0.5, so 0.5 is the same as 1/2, right? How do you get rid of 1/2?
Take
The yeah.
that.
Yep, reciprocal, exactly, I saw the hand motion, that was perfect,
Yeah.
yes. So yeah, multiply him by 2 to get rid of the fraction, yeah. Does that help you decide what to multiply by? We're just gonna multiply by whatever we have to multiply by to get rid of any fraction or decimal, we don't want it around. Yeah. Better?
I'll figure it out.
If not, you let me know, okay? I am here to help you. Alright, SAT 14, the next one, that's another one for you to do for homework. Alright, ACT 25 at the bottom. This one's a little bit of a voter. Okay. So, when you're solving these problems, these multiple equations and multiple unknowns, you need as many equations as you have unknowns. Okay, so if you have x and y, 2 letters, you need 2 equations. If you have 4 letters, you need 4 equations. If you have 6 letters, you need 6 equations. That's the way the rule works. That's the way the math works. Your ACT likes to break that rule. They will give you problems where you have 3 letters, x, y, and z, but you only have 2 equations. Which means, try as you might, there is no physical way for you to solve for all 3 letters. It's not possible, but you might be able to solve for 1 letter. And that's what your problem is about. Okay, so let's look at that method. Let's look at what you have to do. All right. So, this is only on your ACT, guys. If x minus z is 6, and 3x, y equals 3x minus 2 minus 3z, then what's y? All right. And our goal here is to get y. Okay, this is a 3-step process. Step 1. You want to get the letter that you care about, in this case y, and any constants, any numbers, on the same side of the equation. Get all the letters you don't care about on the other side. So the first equation is going to have y in it, so I don't care about him. Let's do this one. On the letter I care about, y, and any numbers, that 2 on the same side. So I'm going to move the 2 over. Okay. Step 1 done. They're lined up. We're good. Okay. I'm going to take this other equation. I'm going to write it underneath this one, but I'm going to flip the sides just so they line up. So 6 equals x minus c. Now, step 1 accomplished. Step 2, I want to make the side that I don't care about, the right side here, I want to make them look the same. I want to make them be equal. So what can I do to the bottom equation to make it equal to the top? Multiply by 3. So I'm going to multiply this side by 3, and it's an equation, so I've got to multiply the left side by 3. So 3 times 6 is 18. And then this will be 3x minus 3z, and I'm going to cross out this middle one just so I don't accidentally look at it. That's step 2. Get the side you don't care about to be equal. Step 3 is just applying a little common sense. If the right sides are equal, then your left sides would have to be equal too. So that means y plus 2 has to be 18. Solve for y must be 16. That's how we figure it out. There's other ways to do it, but that's how you get there. That's about the shortest way I found. questions, okay? Alright, again, only your ACT does that. Alright, next page. Before we do the two problems on the next page, I gotta show you an example. Alright. Let's say we had 2x plus 3y equals 4 and 6x plus 9y equals 12. Okay, this is a random problem. It's not in your packet. What's your pattern here? How'd you go from 2 to 6, 3 to 9, and 4 to 12? You're just multiplying by 3, right? And that's true all the way across. This is times 3, this is times 3, this is times 3. Okay. If that's the case, if you have a pattern that runs in all 3 places, that means that there are infinite solutions to this set of equations. Okay, so if you have the same pattern as everywhere, this is infinite solutions. Now, let's change one number. Let's say this is 4x plus 3y equals 4. And 6x plus 9y equals 12. So the only number I've changed is the first one. So now my pattern still holds true here and here, but it fails here. So I have 1 point of failure and 2 patterns. If I have 1 failure and 2 patterns, this is no solution. Okay? I don't care where that failure is. It can be anywhere. But if I have 2 patterns and 1 failure, there is no solution to this system at all. There's no value of x and y that will make that work. Okay. Let's use this shortcut to help us with the next problem. SAT 23. In the system of equations below, C is a constant, so it's just a number. For what value of C will there be no solution, so we're down here, 2 patterns and a fail, to the system of equations? So we need 2 patterns and a fail. Look at your equations. 2x plus 3y is 5, and 4x plus cy is 8. What's your pattern? How do you go from 2 to 4?
Times 2.
Times 2. There's your pattern. You're never going to be looking for the pattern from 5 to 8. They're always going to give you some basic pattern. Okay. So your pattern is times 2. Does that work from 5 to 8?
No.
So there's your failure point. So you need 2 patterns and a fail. You have 1 pattern and a fail right now. So is 3 to C going to be a pattern or a fail?
Pattern.
It's going to be a pattern. So multiply with 3 times 2. 6. C's got to be 6. That way you get 2 patterns and a fail. Yeah.
If you just have 1 pattern and 2 fails, is it 1 solution?
1 solution. Yeah. If you have anything else besides this, it's 1 solution. Good question. Okay. Any questions on number 23? All right, 15 is yours to do for homework. I'm going to tell you, every single SAT test I have pulled for the last 2 years has had one of these problems on it. Okay. All right, word problem down at the bottom. It's a long word problem. Anything that long, there's got to be a shortcut. All right. I was trained as an engineer. We're always trained to look for efficient ways to do things. I'm like, we're either really lazy or we're really efficient. Take a look. All right. So, number 9. Here's the trick to these guys. Cole, sir, do you have a question? You just stretch it.
Yeah.
What's
Can we apply your 3 steps for the word problems for every word problem, like this one too, or?
No, those are for linear. That's for developing a linear equation out of a word problem. Good question, though. I know, I wish. These actually are going to take less work. Here's your shortcut for these guys. Anytime you're doing 2 equations and 2 unknowns like this, if you look at your answers, you see you got 2 equations, 2 unknowns. Your shortcut for this is to follow the money. It's like anything else in life. If you really want to know what's going on, follow the money. Okay? All right. So, as I'm reading this problem, if it doesn't have to do with money, I don't care. I'm ignoring it. So, blah, 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 blah. They are selling lemonade for $1.07. Okay, that has to do with money. I care about that. So $1.07 for lemonade. Got it. Chocolate chip cookies are 78 cents each. 78 cents for the cookies. Got it. Customers put by card, don't care. 47 customers, don't care. That's not money. They made $45.94. That's money. Okay. So the amount of lemonade they sold and the amount of cookies they sold, when I put those together, I should get $45.94. The only problem is in my answers, I don't have L's and C's, I have X's and Y's. So I gotta figure out which one's X and which one's Y. That's typically in the last sentence of the problem. So if I go to the end, lemonade is X. So this should be an X, not an L. Which means cookies better be Y. So that should be my money equation. Go to your answer choices. There's only one answer that has that equation. Look at them closely. Which one is it?
Is it B?
It's B. That's it. It's the only one that has this equation. Okay? So if you follow the money, you're only going to have to solve one equation, and we don't even care about the other one. Right? That's it. Those word problems can be that fast when you're doing 2 equations and 2 unknowns. On your next page at the top, number 1 is yours to do for homework. It's just like what we just did. Again, follow the money. It's just healthier. You get zucchinis and cucumbers instead of cookies and lemonade. All right. Inequalities. We're actually going to skip over inequalities. This is yours to do for, try doing it, see if you have any problems. It doesn't make up a big part of the test, but if you have issues with it, let me know. So we're going to skip over that section. We're going to go all the way to page 15 to foiling and factoring. As you guys know, you'll get my worked out packet in your email, so you'll get to see how to do them. And if you have issues, let me know, and we'll schedule something to go over it. Okay, foiling and factoring. Let's talk about that. So foiling and factoring problems that are strictly factoring problems and nothing else only appear on your SAT, not your ACT. Your ACT will have factoring on it, but they're going to be part of another problem, okay? So when you see the factoring problems in here, they're all going to be SAT problems because your ACT doesn't have strictly factoring in it. It's got that as part of something else. All right, so you do need to know your quadratic equation. I put it up there kind of at the top. It's x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Don't ask me to slow it down, I'll screw it up. But it's up there at the top right hand corner. It's also in your formula packet. Make sure you do know it. So there are going to be times where you get something where you can't factor it. If you can't factor something, but you still need to find the roots, you need to use your quadratic equation. That's why it's there. Okay. You have a couple of basic factoring patterns kind of in the middle of your page there. You got difference of squares and perfect square trinomial. They're kind of set off in the center. Let's talk about the difference of squares one. So your difference of squares looks like this. If you have x squared minus y squared, it's going to be x minus y times x plus y. Okay, now you're probably not used to seeing it all with letters. You're probably used to seeing like x squared minus 4. Okay, so if we have x squared minus 4, they're both perfect squares. You can take the square root of both of them. So that means that you can apply the perfect squares pattern. All you do is split up your letters, so it becomes x and x, and then take the square root of 4. So square root of 4 is 2. So we're going to put a 2 in each spot, and then one gets a plus and one gets a minus. Doesn't matter who goes where. And you're done. That's factoring a difference of squares. Okay. And again, that works for anything where you can take the square root. So 4, 9, 16, 25, etc. How can we make this harder? We can make this harder because any even exponents will work with this. So it's not just x squared minus y squared. It could also be x to the 8th minus y to the 6th. Those are even exponents. Any even exponents can be factored using different squares. Just simply split your exponents in half. So half of 8 is 4. Half of 6 is 3. And one gets a plus and one gets a minus. Again, it doesn't matter who goes where. And that's difference of squares. Okay. Your other one on the page is the perfect square trinomial. If you recognize that shortcut and want to use it, that's great. If you don't worry about it. It's going to come out in the wash when you do your normal factoring of trinomial, okay? So that one's really not that important. Your bottom line when it comes to factoring problems is if your brain sees something and goes, ooh, I could factor that. Go ahead and factor it. If your brain sees something and goes, ooh, I could FOIL that, I can multiply it out. Go ahead and FOIL it. Even if you don't know what comes next, you're probably on the right track. So just go ahead and take that first step. Okay. All right, brain exercises down at the bottom. Your first problem is x squared minus 9, which again follows our difference of squares pattern. It's just like the x squared minus 4. So split your letters, x and x. Square root of 9 is 3. So 3 and 3, one gets a plus, one gets a minus, and you're done. It's that simple. Don't make your difference of squares hard. Okay, number 2. We're going to factor a squared minus 8ab plus 16b squared. All right, a lot of students don't like these when they have the extra letters on them. No problem. Take them off. Get rid of these. We're going to take them off for right now. I'll show you how to put them back on later. So we're just going to do a squared minus 8a plus 16. Okay. Now this just becomes a normal factoring problem with a trinomial. You're going to work right to left. So start at the right. We need factors of 16 that add to give you negative 8. Okay. So factors of 16 that add to give you negative 8. Work right to left. Okay. So factors of 16 that add to give me regular 8 would be 4 and 4. To make it negative, just make them both negative. So negative 4 and negative 4. So a minus 4, a minus 4. Now, remember those b's we took off? Stick them back on your 4s. Okay, and you're done. You're gonna, if you FOILed that out, you'd wind up with the original thing that has the b's on it. Okay. So really dealing with those second letters isn't that hard. You just take them off and just put them back on at the end. We can also write this as a minus 4b quantity squared. Which way you want to write it just depends on the problem you're doing. All right, we're going to skip the problem next to it, which is t squared plus 6rt plus 9r squared. It's just another one just like what we just did. Down at the bottom, you have two things about foiling. I'm going to assume that most of you can FOIL. Again, you'll see in the packet that I sent you with all the answers, how to do it. If you have a problem with FOILing, let me know. And we'll work on that. Okay. The next page is a whole factoring lesson for anybody who doesn't know how to factor. Again, you'll get the answers in that by email. But let's go to the bottom where it says example 1 and example 2. Those are the ones you want to work. Okay, so we're going to look at two different methods to factor when you have a number in front of your squared term. We're going to look at the box method, we're going to look at the AC method. So the 2x squared plus 7x plus 6, we're going to do the box method on this one. And again, if you have a method that works for you, do it however you usually do it, however you're comfortable. Okay. All right, so if we're doing the box method, the first thing we're going to do is do a times c. We're going to take that 2 times the 6. So 2 times 6 is 12. I am looking for factors of 12 that add to give me 7. Okay. So once you get to 12, you work right to left. So factors of 12 that add to give me 7. 1 times 12, 2 times 6, or 3 times 4. So 3 times 4 adds up to 7, so I'm going to use the 3 and the 4. Once you have that, you draw the spiffy box for which the box method is named. That's not big enough. Try it again. Okay, in the box, the first term, your 2x squared, goes in the upper left. Your last term, 6, goes in the lower right. The two numbers that you found, your 3 and your 4, go in the other two slots. Doesn't matter who goes where. Okay? I'm going to put the 3 in the lower left, and they get x's. So it's 3x and 4x. All right, now, we are going to factor to the left, and then we're going to factor up. So we're going to start by factoring to the left. Okay? So we're factoring out the GCF. So if we factor to the left, we're looking for what goes into 6 and 3x. So 6 and 3x, we can take out a 3. Come across the top, 4x and 2x squared, I can take out a 2x. Okay. Now let's go up. So on the left, I've got 3x and 2x squared, I can take out an x. 6 and 4, I can take out a 2. My factors are the things on the outside of the box. So my factors are, on the left side, I have 2x plus 3. And across the top, I have x plus 2. And that would be, all I'm doing here is just trying to factor. I'm not trying to solve for x, I'm just trying to factor. So that would be my answer at that point. Questions on the box method? Once you get this method under your belt, it's really fast. Yes, ma'am.
I don't really get the part where you start dividing what you're really doing there by the 12 when you go down and you end up getting the 3 and 4.
These are just the factors. So the factors are 12 are 1 times 12, 2 times 6, and 3 times 4.
Okay.
That's just how I get 12. Okay, example 2, 3x squared minus 2x minus 8. 2x minus 8. So this one we're going to do what's called the AC method. This is the method I did before when we did the extraneous problems. So AC method, again, starts off the same way as the box method. I'm going to do A times C. So A times C is 3 times negative 8. That gives me negative 24. And then work right to left. So I'm looking for factors of negative 24 that subtract to give me negative 2x. Okay, so factors of 24, I got 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Okay. So to get negative 2, I'm going to need a positive 4 to negative 6. Right there. Okay. So in the AC method, you replace your middle term, your negative 2x, with those two numbers that you just found. So 3x squared, and again, order does not matter. So I'm just going to take them in the order I wrote them. There we go. And then we factor by grouping. So take the first two, I'm going to take out an x, and I'll have 3x plus 4. Second two, I'm going to take out a negative 2, and I'll have 3x plus 4. My parentheses match, so life is good, I've done it correctly. So pull out the 3x plus 4, and again I can cross it out if it helps you see what's left, and I get x minus 2, and then that would be my factors form. Okay. Again, whatever method works for you, or if you have a different method that works for you, that's fine, as long as you can factor. If you can't factor, that's something you definitely want to talk to me about, because this is important. Alright, it's good. Let's look at how this shows up on the test. We can get through a couple problems real quick. Alright, SAT number 16 at the top of page 17. In the expression x squared plus kx plus 12, k is a negative integer. Which of the following is a possible value of k? Well, first of all, if k is a negative number, what answer can you immediately get rid of? Yeah, one down. Alright, so rule out D. That obviously is not my answer. So we have x squared plus kx plus 12. Okay, so if I was going to factor this in a normal way, I would do factors of 12 that add to give me k. Again, work right to left. So let's just list out our factors of 12. 12 got 1 times 12, 2 times 6, and 3 times 4. And I know I'm adding because of this. So 1 plus 12 is 13, 2 plus 6 is 8, 3 plus 4 is 7, and I know again that these have to come out to be negative. The only one that's in my answer choices is negative 13. So my answer has to be negative 13. Okay. All right. This is not your typical factoring problem. It's one type you can encounter, but the majority will not look like that. The majority are going to look like your next three. So let's look at number 11. So the majority of your factoring problems are going to involve 3 steps. Your 3 steps to your factoring problems are number 1, factor, shockingly. Number 2, substitute. And number 3, calculate. Those are your 3 steps to your factoring problems. Okay. So number 11. If 2x minus 3y is 5, what is the value of 4x squared minus 12xy plus 9y squared? Okay, so we know 2x minus 3y equals 5. And we're looking for 4x squared minus 12xy plus 9y squared. Okay, so here we've got 2 letters, so I would drop the y's and put them back on later. So I would just have this to factor. This is going to require either, again, you got a number for your square term, so that's going to require either AC method or box method. So to save time, I'm going to tell you that this factors into 2x minus 3 times 2x minus 3. Okay, and then those y's that you took off, put them back on. Okay, so we've got it factored. Our next step is to substitute. 2x minus 3y. Oh, 2x minus 3y is 5. We know that from the problem. So 2x minus 3y is 5. 2x minus 3y is 5. 5 times 5, calculate, is 25. Here's your answer. Okay, do you see how those 3 steps work? Factor, substitute. Alright guys, next 2 on the page are yours to do for homework. 8 and 11. And we will stop there. We will finish off the rest of this packet next time. And then we'll dive into the next one.